All right, so we have 2.7, which is absolute value inequalities. And our objective is to graph absolute value inequalities. Okay, just a couple of notes that we need to make before actually doing any type of examples. One is very similarly to graphing linear functions. If it is greater than or less than with no equal to, it will be a dashed v, whether it's like normal or the reflection where it's upside down. But if it's greater than or equal to or less than or equal to, it will be a solid v. Okay, so that is very important to note, very much like our linear inequality. So absolute value works the same way. Now, if you have greater than or equal to, you shade above the vertex. Okay, so therefore, like let's say you have a regular v and it's greater than, you shade above the vertex, which is technically inside of the v. However, if you have the reflection, when you shade above the vertex, that's actually everything outside of it. So you don't want to think like, oh, greater than, you shade inside the v. No, you shade above the vertex. So if above the vertex is inside the v, then you shade inside the v. But if above the vertex is outside the v, then you shade outside the v. So similarly, if you have less than or equal to, you shade below the vertex. So for example, if you have a regular v, below the vertex is underneath. So that means that it's actually around the v, it surrounds it. But if you have the reflection, the upside down v, below the vertex is actually inside the v, and that's where you would shade. Okay, now trying to kind of, what we're doing really is linking our 2.5 and 2.6 where, you know, we'll have to determine whether we need to find the vertex in a left coordinate and right coordinate like we did in 2.5, or we might be able to do a translation. Like we did in 2.6. So you kind of have to determine that. Now you can always just find the vertex, a left coordinate and a right coordinate. However, if you wanted to take the shortcut and do the translation, that's fine too. So let's look at our first example that I have here. And so I have y plus 2 is greater than the absolute value of x minus 4. So first I have to get y by itself. So I have y is greater than the absolute value of x minus 4 minus 2. So this is actually what we're going to be working with. Now I'm looking at this and I'm seeing that the coefficient for the absolute value is a positive 1. I'm seeing that the coefficient for x is also a positive 1, even though it's not written there. You can write it in if you would like. Therefore, I can actually use the translation, so I'm going to, because I like to be able to use the translation if at all possible. So using the translation, I'm going to shift 4 units right. Looking at the inside here, I'm going to shift 4 units right and 2 units down. And remember with this is these are 4 units right and 2 units down from the origin. So always remember that it's from the origin. Okay, so let's go ahead and draw our vertex. So we're going to go 4 units right and 2 units down. And then, again, this is an upside down V, so I'm going to go 1 to the right and 1 up, and 1 to the left and 1 up to make my V. Now, I have to pay attention to the inequality sign. The inequality sign is just greater than, so that means that I do need to have the dash, and I kind of went off the graph there a little bit. And because it's greater than, you shade above the vertex. Above the vertex happens to be inside the V. And then I'm good to go. I have everything completely graphed. So that is the basics of what you're going to be doing with this. Okay, so let's look at another problem. Problem number 2, where I have y minus 3 is less than or equal to the absolute value of 1/2 x, plus 1. Okay, so first what I have to do is I have to get y by itself. So I have y is less than or equal to the absolute value of 1/2 x, and that's going to be a plus 4 because I had to add 3 to both sides. So this is actually the equation that we're working with. Now please note that the coefficient for x is not a positive 1, so I cannot do a translation at all. So we have to kind of go back to 2.5 where we had to find the vertex and such. So first we're going to find the vertex. And remember, you set the guts of the absolute value equal to 0 because that is a distance from 0. So I would divide by 1/2, or in other words, multiply by 2/1. And then I get x equals 0. And remember that the y value is just the c there. Okay, the y value is just the c value that's tacked on to the end of the absolute value. So then let's talk left coordinate and right coordinate. Again, you get to choose the x value for it. I personally, I'm going to go ahead and choose -2 and 2 for my left coordinate and right coordinate respectively. And truly the reason why I choose that is because I know I have to multiply by 1/2 to reduce the amount of fractions I have. I know that an even number will give me a whole number. So I'm kind of being, I guess, maybe a little bit selfish of my time, but you know, it's your call. You can choose again, whatever works for your left or right, that's okay. So now what I'm going to do is I've got y is less than or equal to the absolute value of 1/2 times -2 plus 4. 1/2 times -2 is going to be a -1. The absolute value of -1 is 1, so I get 1 plus 4, which is 5. Okay, so my y value is 5. And then my right coordinate, because I was equidistant from my vertex, I can actually just use that same y value. But again, you can always double check yourself if you're ever uncertain. So now let's go ahead and graph this. So kind of, again, going back to our 2.5, nothing too crazy with this. So I'm going to graph my vertex of 0, 4. You know what? I'm going to actually make this a little bit lower. I'm going to graph my vertex at 0, 4. And then I have to graph at -2, 5. And then at 2, 5. Now, going back, it is less than or equal to. So I am going to have a nice straight line that is solid. Okay, and then because it's less than, I have to shade below the vertex, and below the vertex happens to be on the outside of that absolute value. So I'm going to shade on the outside of it. So if you're ever unsure, like, you can do kind of what I did. I started shading below it, and then that's where I was able to tell the location. Okay, it's surrounding that V. Okay, so that's it for this part of the video. I've got a couple more things I would like to discuss in the next part of the video, so hold on for part 2.